Welcome back. Today we are going to be solving this initial value problem where we're given that dy over dx is equal to x plus 1 over the square root of x with y of 1 equaling 3. All right, so the first thing we need to do is we need to rewrite this differential equation in something that's a little bit easier to integrate, right? So that's our first step here. So what I'm going to do here is I'm going to write this as x plus 1 over x is the same thing as x over square root of x plus 1 over square root of x. And then x over square root of x, well, that's really just the same as x over x to the power of a half plus 1 over x to the power of a half. And then that, if we recall that the subtraction rule for when we divide like exponents with the same base, we would get 1 minus a half, which is a half. So we get x to the power of a half here. And then 1 over x to the half is the same as x to the power negative a half. And so now we've rewritten this in something that looks a lot easier to integrate. This looks very complicated to integrate, whereas this really does not. All right, so now our goal is to integrate both sides. So we're going to find y of x, right? Once we integrate dy dx, we just get y of x, and that's going to be equal to the integral of x to the power of a half plus x to the power negative a half dx. And then let's actually take the integral. So what would x to the power of a half's integral or antiderivative be? Well, that's going to be x to the power of 3 over 2, and then times 2 thirds out in front, right? Because let's say we were to actually take the derivative of this, the 3 over 2 and the 2 thirds would cancel, leaving us with no coefficient, which we don't have a coefficient here. And then 3 over 2 minus 1 would give us 1/2, so we'd get the correct exponent. And so that's a check you can do after you take the integral to make sure that you are correct. And then we'll do the same thing with the other one, right? What is x to the power negative a half's antiderivative? Well, in this case, we know that we would have to add 1 up here, so we would end up with x to the power of a half. And then we would have to have that times 2, so that the 1/2 and the 2 when multiplied, when we're taking the derivative of this to get back to here, we would end up with x to the power negative a half. And then, of course, I'll put plus c, since if we're taking the indefinite integral, we want to add c because the indefinite integral is going to be representing any possible antiderivative there, all the whole set of all the possible antiderivatives, not just any particular one. And c is going to be our constant of integration there. All right, so next I'm going to use the initial condition to solve here. So for y of x, I'm going to plug in 3, and for x, I'm going to plug in 1. So I'm going to get 2 thirds times 1 to the power 3 over 2 plus 2 times 1 to the power a half plus c. And this way we're going to be able to find out what c is in this particular example here specifically. So we're going to get 3 is equal to 2 thirds plus 2 plus c. So therefore, if we subtract, we get c is equal to a third. And so going back to what's the final solution then, I'm going to rewrite this line, but with the proper c rather than just a plus c that could potentially be any of the antiderivatives of the original without regard to the condition of y of 1 equaling 3. We would end up with y of x is equal to 2 thirds x to the power 3 over 2 plus 2x to the power of 1/2 plus 1/3, right? So that's our final answer. And that's essentially just me copying from up above and adding in the 1/3 since that's what we found out in particular. All right, well, as always, if you have any questions, feel free to leave those in the comment section, and we'll see you for the next one.